Yo, what's up? It's your boy, Mr. AC. And what I got for you guys today is going over primarily, and we are on year number. So let's go ahead and get started. All right, we're moving along to 2003 Form B, and in this particular problem, it's actually a little bit more challenging because this problem is differentials and it's what I will call a wildcard problem, meaning it doesn't have that format that we usually see where it's like, here's your differential equation, find the original, or find, the equation of the line tangent. It's kind of unique and different. So let's go ahead and go into it and give it a try, because it's always good to go through these wildcard ones that show up every now and then so that we make sure that we are feeling real good and real tough at these questions. So this problem says we got to take the second derivative and evaluate it at 3. They gave us the first derivative. Now this has a square root function in it, and there's also x and f of x. So that pretty much tells me this has got to be, my friends, the product rule. So what I'm going to do first is I'm going to rewrite it like this. I'm going to rewrite it with f of x to the power of 1/2. Remember, we're not given a calculator here, and the only way to do this is to really essentially put it to a fractional exponent, right? If it's square root, it's to the power of 1/2. So now we can go ahead and take our second derivative, and we should be able to take the second derivative now much more efficiently than leaving the square root, because that would be pretty hard. I mean, I don't even know how to do that. So let's go ahead and get rolling. The derivative of the first is 1. So 1 times, we leave the second alone. So f of x to the power of 1/2, like this. I should write it a little bit bigger, my apologies. Plus, leave the first alone. So x times, now we got to take the derivative of the second. Well, just so that you can see it in this corner, I'm going to do it right here just so that you get a chance to see it, maybe in this little corner, and then we'll put it down here. Well, we're going to bring the 1/2 down like we normally would. So this is going to be 1/2 f of x. Let me put a set of parentheses right now. To the power of what? Well, we need to subtract by 1 because we're taking the derivative. So 2 over 2, so that we can get kind of common denominators, right? 1 minus 2 is -1. So this is -1 over 2. And then we got to take the chain rule, right? Because we took the derivative of the outside, but we got to take the derivative of the inside. So we're going to do that. What's the derivative of f of x? Well, f of x is a function. So we're going to write the derivative of f of x is strictly just f prime of x. So that would be our derivative of the second, which looks pretty tough. And then what I would do, because again, this is not calculator active, I would maybe rewrite this as f prime of x divided by, right? This negative exponent means divide f of x by this power. Notice how we already have a division symbol and the 2's underneath it. So we're going to have 2. And then I'll maybe just write it here, parentheses, f of x to the power of 1/2. Right? That would be kind of my ideal setup right now, because this means divide f of x to this power. We already have the 2 underneath with this division symbol. So this is my finalized kind of problem. So I'm going to write it over here. F prime of x. All right, there it is. And again, I will try to rewrite these a little bit better. I apologize. Obviously, I wrote it really small here. But nonetheless, we took our second derivative correctly, so we would get 2 points at minimum for this. And now we need to plug in f double prime of 3. Now we need to evaluate what is the derivative at f double prime of 3. So let's go ahead and plug it in how it looks like so far. Because this is a 1, we don't need to write it. So here it is. I'm going to write it a little bit bigger. This is going to be f of 3 raised to the power of 1/2. That's basically the square root plus x. This is 3. This is f prime of 3. Notice how the x, I just pretty much grouped it with the numerators, which you can because there's an invisible 1 underneath. So x times f prime of x. So that's why it's just 3, because I plug in the 3 for the x, and then f prime of 3 divided by 2. And then we're going to go ahead and do the exact same thing. F of 3, bam, to the power of 1/2. And that's what so far, our formula / second derivative should look like. Now, here's a couple of important things to keep in mind. We already know what f of 3 is. F of 3 is 25. So meaning anywhere that I see f of 3, I'm going to circle them. This right here and this right here, I can replace that with 25 because that is the value. But we still need to find out what f prime of 3 is. Well, here's the good news. We were given f prime of x up here. So that means we can plug it in. So let's do this in this corner. F prime of 3 is equal to 3 times the square root of f of x. Well, this is f of 3. Pretty confusing because it involves a lot of f prime, f double prime. But what is f of 3? We talked about it. F of 3 is 25. So this should be 25. So this is going to be 3 times the square root of 25. Well, what is the square root of 25? That is 5. So 3 times 5 and we get 15. So now we know anywhere that I see f prime of 3, which is this right here, I can replace that with 15. So let's go ahead and do that all together. So what's f of 3? Well, f of 3 is 25. So I'm going to write over here. I guess we'll write it in this corner. This is going to be 25 to the power of 1/2. That's really just the square root, right? We rewrote it, but it means the square root. I'm going to rewrite it like this just for now. 3 times 15. We already did that in the previous example right over here, my friends. We're going to divide this by 2 times, well, again, f of 3 is 25. The 1/2 means the square root, so the square root of 25, and it's going to look like this, okay? The square root of 25 over here is 5, plus 3 times 15 is 45. Hopefully I know how to multiply numbers. You know that's an issue for me. The square root of 25 is 5. 5 times 2 is 10, and there it is. 45 divided by 10 is 4.5. I think, yeah, 4.5. 5 plus 4.5 is 9.5. And that would be my exact solution for this problem. Very good. So there is part A, a pretty nice one involving the second derivative, the original, and the first derivative. Let's go ahead and move on to part B. Okay, part B. Again, these problems to me are always some of the toughest ones. So we're going to make sure to always do these ones. And then I'll leave part C as an exercise for you guys. That way the video is not like 30 minutes long and then you get overwhelmed and you're like, Mr. AC, you make these videos too long. All right, let's get rolling. Write an expression for y equals f of x by solving the differential function with the initial condition f of 3 equals 25. Now keep in mind, write an expression for y equals f of x. What that essentially means is we need to find the original. Well, again, I don't want to basically repeat myself every video, but hey, we're in velocity, we're in our first derivative, we need to get back to position that is antiderivative. So let's go ahead and write this out. Okay, let's go ahead and separate these variables. We're going to multiply dx to both sides. So let's multiply dx to both sides to get rid of this. And then we're going to divide by the square root of y. So hopefully this all makes sense. We're going to divide by the square root of y, get rid of this right here. And then what we're going to get is 1 over y to the power of, I'm going to write it as 1/2 because you guys already know I don't like square roots, especially because we're going to have to take the antiderivative, dy. Now, why do I have a 1 on the top? Well, remember, there's just a placeholder of 1. And I like to keep these two separated so it doesn't confuse me, right? Is equal to x dx. So if you notice now, everything is good to go. We can take the antiderivative of both sides because we have finally separated the variables, hopefully nice and well. Now here's the problem. Over to this left side, a lot of times we want to do ln. Well, we're not going to do ln because we actually have a power. Remember, if we get any other power besides 1, that's not going to be ln. That is, we have to rewrite this. We're going to bring this back up. Now, if I flip this side, I don't want to flip this side. This side looks perfect. So that means it's going to become a negative exponent. So what I'm going to get is the antiderivative y to the negative 1/2 dy. This is going to equal the antiderivative of x dx. Now we can take our antiderivative. So let's go ahead and do that. Well, we're going to do this one over here first. We're going to add by 2 over 2 because we're taking the antiderivative. So we're going to add. So this is going to become 1/2 and then we have to divide by it. So this is going to become y to the 1/2 divided by 1/2 is equal to, now this is going to become x squared over 2 plus c. Well, this looks a bit confusing. Again, hopefully from the prior video, how you deal with these kind of makes some sense, right? We got divide, where essentially we can keep flip change, but all that means is we can just bring the 2 up. So this is going to become 2y to the 1/2 is equal to x squared over 2 plus c. Now that we have separated the variables, we've taken the antiderivative correctly. Now we can go ahead and find our C value. Well, the 3 is your X value. The Y value is 25. So let's plug that in here and let's plug in the 3 here. So we're going to get 2. This is going to be 25 to the power of 1/2 equal to 9 divided by 2 plus C. Now remember, 1/2 is square root. What's the square root of 25? It's 5. So this whole thing becomes 5. 2 times 5 is 10. So we get 10 is equal to, this is what, 4.5 plus C. Now we need to solve this. We're going to subtract 4.5 to both sides, and we're going to get 5.5. So now we found our C value. Our C value is 5.5. Again, we're never going to box anything on the AP exam. Let's go ahead and take this now and plug it into here. Let's plug this into here. So we're going to get 2y to the 1/2 is equal to x squared over 2 plus 5.5. Well, now what do? Well, we need to solve for y. So in this case, we need to divide everything by 2. We can divide all of these individually by 2, or you can put a set of parentheses and divide by 2. In my personal preference, I think I personally would just prefer to just divide everything by 2 and just put a big set of parentheses here. That way that's gone, right? Again, remember on the AP exam, you don't need to finish these problems all the way through. So we're okay with that there. Let me go ahead and write it real quick. Now that we finally got this taken care of, well, what do we do to get rid of the 1/2? Well, to get rid of the 1/2, we need to multiply by 2 over 1 to the exponents, right? And if I do it to one side, I have to do it to the other side. Why 2 over 1? Technically, 1 divided by 1 is 1, 2 divided by 2 is 1. Essentially, these are going to cross cancel, right? So that's why I did the inverse of that power. And then we get y is equal to, let me go ahead and rewrite this. Obviously, I wrote it a little sloppy, but you get y is equal to, and then you get this expression right here, all raised to the power of 2, because 2 divided by 1 is 2. So hopefully y'all enjoy just a quick episode going over this problem, which was, I think, a pretty good one. Involved some second derivative, product rule, all that with A and B. I'm gonna leave part C as an exercise for you, and if you have any questions, y'all already know what to do. Just let me know. Take care. Capiche?